So welcome to the special movie on the bromination of the cis or Z-butene. I was going to put little movies within the big movie as I've done before, but I just would have had to do it so many different times. I thought let's just make it its very own main feature. So here we go, the bromination of Z-butene. So here are my tools. This is the molecule. Okay, that's the double bond there. I'm looking at it almost from the top here. Okay, so the planar carbons, 120 degrees, give or take. Methyl group, both on the same side. So purple is methyl. And in a minute, the nasty old bromines will come in and attack. Now, I'm not worrying about a Br2 molecule. I've just got bromine atoms doing their things. Or actually, of course, it would be bromine ions doing their things. So let's start the movie rolling. So it's my bromine now going to come in, and I'm going to turn the molecule so that you can see it properly. So now I'm looking at it flat on the orientation that we had in the teaching movie. There's the bromine coming in from the top, and of course its other bromine is attached to it, ready to leave as a bromide anion. So I was actually doing some narration along with this to give me the timing. I can't remember what other details I was going to say. But anyway, there is the bromine atom ready to come in to make the bromonium ion, which is right there. Okay, so let's have a look at what that looks like. You've got the tetrahedral carbons now, the bromine bonded to both of those carbons with a single bond there. Methyl groups still on the same side coming out at you. So again, pretty little molecule there. Now, of course, the other bromine can only now come in from the other side. There it is. That's the bromide anion that was made. It can only come in from the backside attack, from the anti-attack. Now, of course, it can attack either of those carbons, and that's what gives us the two possibilities. So let's look at it attacking. First of all, I will have it attacking first of all on the left-hand carbon. So we're going to have left hand bottom down to the bromine, right hand top to the bromine. And of course that bond will be broken as the bromine comes in on the left hand carbon, which we'll call carbon 2. So carbon 2 bromine on the bottom, carbon 3 bromine on top. Certainly did a lot of talking over that. Let's have a look. Right, bromine on the bottom, carbon 2 bromine on top, carbon 3. There we are, bromine on the bottom, carbon 2 bromine on top. Now, next thing I'm going to do is assign the absolute configurations for these things. So carbon 2, hydrogen at the back, bromine is top priority. This is the next priority because both these are carbons, but this carbon has a bromine, and then the methyl group is the 3. So we're going 1, 2, 3, 1, 2, 3, anti-clockwise. That one is S. There I am lagging behind, assigning it. Let's look at this one while it's out the way. Hydrogen at the back, bromine on top. 1, 2, 3. So S as well. So both of the ones where the bromine came in and attacked carbon 2, the left-hand carbon, are the SS. And here I am about to show you this one being S as well. 1, 2, the methyl 3, going around anti-clockwise. Right, now let's consider when we have the bromine not coming in at carbon 2, but coming in at carbon 3. Okay, so now the bromine's going to be on the bottom of carbon 3. This bond will be broken, so carbon 2 has the bromine up. Just as I said, I'm so far ahead of this guy. So carbon 3, bromine on the bottom, carbon 2, left-hand carbon, bromine on top. In a minute, I'll go get that little model. There we are, so we're looking for left-hand bromine up, right-hand bromine down. There it is indeed. So let's assign the absolute configurations. carbon 2, hydrogen at the back, bromine number 1, this number 2, methyl number 3, so that's R. Here, hydrogen at the back in a minute. I'll wait for myself to count, but on carbon 3, hydrogen at the back, bromine best, this number 2, methyl number 3, so clockwise R, R.